The process basically consists of these 4 steps: analyzing audio input, creating the particle system, instancing with cones, render setup, and post FX. On this channel, I also post other tutorial videos mainly focused on TouchDesigner. I'd be glad if you subscribe to the channel. Additionally, the project files are available for download on my Patreon. If you find my tutorials helpful, I would truly appreciate your support there. Let's get started. First, I will explain the basic process of achieving audio reactive visuals in TouchDesigner. We're going to start by adding a null pop and naming it null_render. To render in TouchDesigner, you need to prepare a geometry comp, a camera comp, and a render top, and then assign a material of your choice. In this case, we're going to add a constant MAT. We drag and drop the constant MAT onto the geocomp. We're going to add a circle POP. We add an audio file and chop. If we want to use real-time audio input, we can use an audio device and chop instead. From the Tools section of the palette, we add an audio analysis comp, followed by a null chop. We load our preferred audio file into the file of the audio file and chop. By turning on Send Audio to default out, we can hear the audio. We enable each active toggle in the audio analysis comp. We adjust the respective thresholds until we can confirm that the values in the null chop are reacting to the audio. We add a select chop and choose a specific channel, such as kick or snare. To smooth the movement of the waveform, we add a filter chop. We reference the kick value from the null chop to the radius of a circle POP. We add a math chop and set the pre-add value to 1. We will try selecting mid using the select chop. As before, we reference the mid value to the radius of the circle pop, and adjust parameters such as mid threshold, mid gain, and mid add. We add a noise POP. This operator allows us to apply noise to various attributes of the input. Since we are applying it to the default position, P, we can transform the circle by changing the amplitude, exponent, and period values. We will now drive this transformation using the values obtained from the audio. We select kick with a select chop, and reference that value to the exponent of the noise. We will change the color based on the audio. We're going to grab snare from the select chop as well. We copy and paste the math chop and set the pre-add value to 0, then add a null chop. We reference the mid, kick, and snare values to the R, G, and B parameters of the constant MAT, respectively. To emphasize the mid value, we input mid into the scope of the math chop and increase the multiply value. As shown, we create audio reactivity by linking audio data to POP and MAT parameters. This same logic can be applied to SOPs, TOPs, and other operators as well, creating the intro visuals. We add a point generator POP and connect it to a null POP, naming it null_render. We're going to add a geometry comp, camera comp, light comp, and render top. We add a constant MAT. With these in place, our rendering setup is now complete. We're going to add a noise POP. We're going to add a particle POP. We'll set the birth rate to 500, which increases the number of particles generated per second. We'll also set the life expect to 1, which shortens the time each particle lives before disappearing. We're going to add a keyboard and chop. We reference the K1 channel of a keyboard and chop to the initialize and start parameters of the particle POP. By connecting both the noise POP and particle POP to DAT operators, we can inspect the data. In the particle POP, we can see that essential attributes for particle expression have been added, such as velocity and lifespan. We're going to add a noise POP. We drag and drop the noise POP onto the particle POP and select target particles update POP to create a feedback loop. We add a box POP and a copy POP, connecting the box POP to input 0 and the noise POP to input 1. We input partage into the template scale of the copy POP. This causes each box to increase in size from the moment it is generated until it disappears. To reverse this so the boxes shrink over time, we add a math mix POP. We'll use the A to B operation to subtract 1 from partage, and then we'll multiply the result by -1 using A*B. We'll rotate the boxes so they follow the direction each particle is moving. We add a trail POP, setting trail length to 0.2 and trail increment to 0.5. We enable match by attribute and enter part ID. We reference K1 from the keyboard and chop to the reset parameter. We add a line resample pop, changing the resample method to division per line strip and setting divisions to 6. We add a line metrics pop and enable tan. In the copy pop, we enable template rotate to vector using the tan, and set the forward direction to Y. We add a lookup texture pop and ramp top to apply our desired colors. We're going to delete the constant MAT and add a PBR mat instead. We're going to drag and drop the PBR mat onto the GO1 comp. We'll add a light comp and play around with the settings until we get the lighting looking just right. We add an audio file and chop and follow the same steps as before to select an audio file. We add an audio analysis comp from the palette, followed by a select chop. By turning on Send Audio to default out, we can hear the audio. We select kick using a select chop. We add a filter chop and set the filter width to 0.33. We reference the kick value from the filter chop to the exponent of the noise pop, adding -1.2 at the beginning of the expression. We adjust the kick threshold value. We add an SSAO top. Please note that this process is resource intensive, so we should use it only to the extent that it does not decrease the FPS. We add a bloom top. By changing the seed value of the noise pop, we can vary the noise patterns. We set the birth rate of the particle pop to 800. We add a tube pop and connect it to input 0 of the copy POP. We have now successfully created the visuals shown at the beginning of this video.